Hi guys, welcome back to Kothait channel. In this video, we are going to build a machine learning model to predict whether a particular credit card transaction is a fraudulent one or a legal one. In the cyber world, anyone can have our credit card details. Once our credit card details are compromised, cybercrime people will be making the fraudulent transactions against our credit cards. To detect this kind of fraudulent transactions on credit cards, we are going to build a machine learning model which will be classifying whether the particular credit card transaction is a legal one or a fraudulent one. Let's decode the machine learning model. Here we are going to need a credit card transactions data set with the fraudulent ones and as well as the legal ones. So once we have the data set, we'll be doing the pre-processing on the data set. So once we are done with the pre-processing of the data set, we'll be doing the analysis on that particular data set. This is to be called as a data analysis. What we are going to do here is, here we are going to check whether there are any duplicate records are there in the data set or not. If there are any duplicate records are present in the data set, we have to remove those duplicate records. And the next thing is we have to check are there any null records are there in the dataset or not. If there are null records present in the dataset, we have to find the ways to fix those null records or we have to delete those null records. So once we are done with the data analysis, we have to check whether this particular dataset is a balanced one or imbalanced one. The dataset which we are going to use here is completely imbalanced one. So if it is an imbalanced dataset, we have to make it as a balanced dataset by using the two methods. One of the method is called as undersampling and other one is will be called as a oversampling. So once we do all these things, so once the data is ready, we'll split the dataset into two parts. 80% of the data goes to the training dataset and 20% of the data goes to the test dataset. And here we will be creating a logistic regression machine learning model from the scikit-learn. This model will be used to classify the items. So once the logistic regression model is created, we'll be training the model with the training dataset. And then we'll be predicting the future values with the test dataset. So same model will be used to predict the values as well. Let's dive into the coding. Okay, here I have created a folder called credit. Okay, here there is a dataset. Okay, here I'm just opening the Jupyter lab. Okay, typing cmd.exe. Okay, and here I'm just typing Jupyter lab. Okay, our Jupyter lab will open in the browser. Okay, yeah, Jupyter lab is up and running. Now I'm just creating a new one. Rename credit card fraud transaction detection. Fraud transaction detection. Okay, now before going that, we have to install the necessary Python libraries, right? So open command prompt and type in here pip install pandas to read the data from the file to pandas data frame, and the next one is scikit-learn and another one is imbalanced, which will be used to do the data balancing. Okay, so these are the three Python libraries which we are going to use in this tutorial. So if you just press enter, these Python libraries will be installed in your system. I'm not going to install them because I have already installed all these Python libraries in my system. Okay, just closing it. Now importing the necessary Python libraries. Okay, import pandas spd and import not import from sklearn pre-processing import standard scalar. Okay, standard scalar will be used to do the scaling of the dataset. Okay, from sklearn model selection import train test split. Okay, which will be used to do the splitting of the dataset into training dataset and test dataset. And from the sklearn linear model, which is logistic regression model. Okay, and from imb is nothing but the imbalanced dataset. Okay, over sampling import smart functionality. Okay, so we have been importing the necessary Python libraries. Now let's read the dataset. Okay, data is equals to pd dot read underscore csv of credit card dot csv. Okay, so now we have read the data from the pandas data frame. So pd dot read csv, the whatever the data which is there in the csv file, we have been loaded into data. Okay, let's print the first 5 rows. Okay, first 5 rows from dataset. For that one functionality we have to use head. Okay, it will display the first 5 rows from the dataset. If you see here, let me, yeah, okay, it will display the first 5 rows. If you see here, there are total 31 rows are there, 31 columns are there. Okay, so time is one of the column and remaining variables are v1 to till v28. So what is this v1 to v28 fields are like? So this credit card will be having the information about the merchant and the details, personal details about the users as well, right? So for that one, they have been used it as a encoded into the numeric fields from v1 to v28. So which will not be used, which will not be able to identify the user who is using this credit card transaction, who had made, and then who is the merchant. So to avoid to identify, so whatever the information which will be used to identify those customers or merchants has been changed to field names, has been changed from v1 to v28 into the numerical data. Okay, in other terms, I think it is an encoded data. Okay, encrypted data. Okay, and next one is the amount field, and next one is class. Class says that whether that particular transaction is a fraudulent one or legal one. If it is 0, that means a legal one. If it is 1, that means a fraudulent one. And here is the amount. So the amount for that particular transaction has been used. Okay, here is the time, and v1 to v28, the fields are there. Okay, and what we have to do is data dot info. So info will give us, we are not able to see what are the columns between v9 and to v21, right? So and what I'm doing is I'm just printing the data.info. So it will give us the information about each and every column. Okay, so total we have the 30 columns, 30 float columns, and one of the column is an integer column, so which is class. Class is an integer column, and remaining total we have 31 columns. So 30 out of 31 columns are having float 64 data type, and one of the column is int64. Okay, so first one is the time, and remaining ones are v1 to v28. Okay, all these are floating columns and all these are non-null columns. Okay, so that is what we are going to get from the data.info. Okay, and the next step what we have to do is we have to check if there are any null values. Null values check. How we are going to do is data.isNull. If you press enter, so it will be created a pandas data frame whether that particular value in that particular row is a true or false. If it is false, in the sense it is not a non-null value. If it is true, in the sense it will be having a null value. So to identify, to get the summation of all the, whether there are any null values are there in that particular column or not, we have to do the summation as well. Is null with an extension of sum. Okay, if you see here, all the columns are having 0 records, so that means we don't have any null records. So null check has been passed. So the next check is duplicate check. So before going duplicate check, we have to print the shape of the data set. Data.shape. So if you see here, the data says gives that, so we have the 284807 rows of data set with the 31 columns. Okay, that is without doing the duplicate records. Okay, if there are any duplicate records, we have to delete those duplicate records, right? So there is an inbuilt functionality in the pandas to remove those duplicate records. Data drop duplicates. Okay, in place is equals to true. Okay, so what exactly happens is, here we are taking the data set and we are removing the duplicates. In place is equals to true, in the sense in place says that the whatever the transaction, that drop duplicate transaction has to be applied on the main data set, which is data, and here we are removing the duplicates. So let me execute it. So it's done. Now let's print the data.shape. If you see here, before removing the duplicates, we have 284807 records. After removing the duplicates, we have 283726. So there is a huge difference, right? Almost 800 to 900 records are there as a duplicate records. Okay, which we have removed them. So now what we have done is, we have loaded the data into from the CSV file to pandas data frame, and we have just checked the top 5 rows, and we have the total 31 columns. Out of those 31 columns, 30 columns are floating columns, and one of the column is as a int column. Okay, and here we have time column, and we have checked whether any null values are there or not. So we don't have any null values, so we don't have to do any fixing, but we have identified duplicate records, so we have removed those duplicate records. Now let's print the data. Okay, you see here is the data, and time column is there. I don't think time column makes any sense in detecting whether that particular transaction is a legal one or a fraudulent one, so let's remove that column. Okay, data dot drop off columns is equals to time. Okay, and here I have to do one more thing, in place equals to. Okay, here what we have done is I print the data, so we have removed the time column. Now we have the columns from v1 to v28. Okay, these are the different columns, okay, with the different details, and the next column is the amount column, and next one is the class. Let's see how many values are fraudulent transactions are happen and how many are legal ones. Okay, and what we have to do is data dot, the column name is class, right? Okay, data dot class dot value counts will give us the unique values with respect to the counts. So total 283,253 columns are having the legal transactions, and only 473 are the fraudulent transactions. If you see here, this data is completely imbalanced data set. If you have legal transactions are almost 90%, 95%, and just 1 or 2% of the only fraudulent transactions are there. This is a very imbalanced data set. We have to make this imbalanced data set as a balanced data set by using the two methods. One of the method is called as the undersampling, and another one will be called as the oversampling. Okay, which we will be discussing further. And before going over there, so let's see that how the data is looking at the fraudulent transactions and how the data is looking at the legal transactions. So legal transactions is equals to data of class, where class is equals to 0, that means that particular transaction is a legal one. Okay, where it is a fraud one, where that data class is equals to 1. Okay, data class equals to 1. Okay, now let's check the legal dot shape. Okay, and fraud dot shape. So we have 283,253 records as the legal ones, and only 473 are the fraudulent ones. Okay, legal dot describe and fraud dot describe. So what exactly this describe does? So describe will describe the give us the insights about the numerical fields in the data set. Okay, so whatever the legal transactions which are happened, if you see those legal transactions amount field, I think these are the fields which we cannot make anything, but if you look at the amount, and it is this to call that let me do only for the amount field. Okay, if you see here, the main of the legal activities, the amount field is 88, and here it is 123, and standard deviation is 250, and here it is 260. And if you see this maximum value in the legal transaction is 25,691, but if you see here 21.25. Okay, these are the insights that we can get from the legal transactions as well as the fraudulent transactions. Okay, now as we have coming back to the data set. Okay, value counts. Okay, here if you see here, the data set is an imbalanced data set. Okay, we have more number of legal transactions and we have less number of the fraudulent transactions. If we feed this kind of data set into the model, so the model most likely feed it, think that the transactions as a legal transactions, even though because we have very less number of transactions to identify, the model to be prepared to identify the fraudulent transaction. So in that case, we have to do the data balancing. Okay, so we have two methods here. One of the method will be called as undersampling. Okay, and other method will be called as a oversampling. Okay, first we will be looking at the undersampling. So undersampling, what we will do is, so here we have the fraudulent transactions as 473 transactions, right? Same way we have to take only the 473 records from the legal transactions as well. So whatever the fraudulent transactions we have, same number of transactions only we will take, the same number of for legal transactions only we will take. Okay, that's what it is called as undersampling. So we are reducing the count. Okay, we are matching this fraudulent transaction legal transactions counts with the fraudulent transactions count. So how we are going to do is, so fraud, anyways we have another setup, fraud dot shape, right? So 473. Now legal and score sample. Okay, what we have to do is legal dot sample. If I mention the sample, okay, it will give us an option n is equals to how many records, 473 records. So what will happen is we have the legal records around 283253, right? Out of this 283253, so we will be taking only the sample of 473 records, because same number of records we have for the fraudulence as well. Okay, if I press enter and if I type this legal sample dot shape, see, now here also we have the only 473 records for the legal records and fraudulent records. So what we have done is we have taken out of we have taken only 473 out of this 283253 records from the legal transactions. Okay, now we have to merge this legal and fraud transactions to make it as a complete data set. Okay, data underscore undersample data undersample pd dot, we have to concatenate both the records, right? Legal underscore sample one and the fraudulent transactions. So total 473 and 473. Okay, records. Next, ignore index is equals to true. Okay. Spelling mistake. Okay. Now let's check this data set. So here we have 946, 473 are the legal and 473 are the fraudulent transactions. Okay, and yeah, let's check the data underscore undersample dot shape. Yeah, we have 946 records with the 30 columns. Okay, and data underscore sample dot class dot value counts. So we have fraudulent transactions of 473 and legal transactions as 473. So now our data is balanced data set. Now once we have this data set, what we have to do is we have to do the identify whether what are the input columns and what are the output columns. Okay, so except the class which will says that whether that particular transaction is a legal one or a fraudulent one, so this column will become an output class, output variable, and remaining columns will 29 out of this 30 columns will become the input columns. Okay, let's do the data split. X is equal to input data under sample dot drop columns is equals to class. So except the class column, so rest of the things goes to the input data set, and y is nothing but the output data set, which is a class column. Okay, now we have x dot shape, we have 29 columns, and y dot shape, we have 946 columns, only single column. Okay, and now once we have identified the input data set and output data set, we have to feed it into the model. Okay, before going to so we have identified the input data set and output data set. Okay, and we have to split this data set into training data set and test data set. Okay, what we have to do is splitting up the data set, x train underscore x text and y train comma y test is equals to, we have imported one more functionality, right, in the starting, train test split. Okay, we have to pass x comma y and text size is equals to 0.2. So what we are doing is 80% of the data goes to the training data set, and where we have mentioned test size as 0.2, so that means 20% of the data set goes to the testing data set. Okay, just executing it. Yeah, that's done. Now let's print this x train dot shape and x test dot shape and y train dot shape and y test dot shape. Okay, You see here 756 records. So out of 946, 756 out of 946 goes to the training data set, and remaining 190 records are goes to the test data set. Okay, so once we are done with that, we'll be doing the scaling of this data set. Okay, by using the standard scaler. Okay, and what we are going to do is we are going to create an object for the standard scaler. Okay, so once the scaler has been created, so x train data, that is the input data that needs to be scaled. Okay, scale is equals to scalar dot fit underscore transform of x underscore train. Okay, here instead of test we have to make it as a, instead of train we have to make it as a test one. Okay, so we are scaling the test data set and train data set. So once the scaling of the data set is done, we are going to create the model. Model is equals to logistic regression machine learning model. So once the model has been created, we have to train this model. Okay, so training the model dot fit with what? Training data set. Okay, x underscore training scaled data for the x. Okay, and y underscore train. Okay, and so logistic regression machine learning model has been created. Now let's predict the values. Predictions is equals to model dot predict of, so for which values the model has been trained on the training data set. So once the model is trained on the training data set, we have to find out the predicting the values for the test data set. Okay, x underscore text, here we have been predicting the values. Sorry, scale data set, right? X underscore test underscore scale. Okay, now we have made the predictions. So these are the values, zeros and ones from the predictions. Okay, now what we have to do is we have to compare these predictions, whatever the model has been predicted, with the actual values, which is nothing but the y underscore test. Okay, y underscore test will be holding the actual values for this test data set. Okay, so we have to do the comparison. So how we are going to do is we have functionality in sklearn from sklearn dot matrix import accuracy score. Okay, and here we have to find out the accuracy score between the predictions, right? Prediction prd comma y underscore test actual values. Okay, so the prediction value is 90%. The values are ranges from 0 to 1. If the value is nearest to the 1, then that means our model is doing very good job, and if it is nearest to 0, that means our model is not performing well. Okay, so our accuracy score is 0.9. So how we have done? So we have done it with the undersampling. So whatever the data set huge number of 283253 of legal transactions, we have only extracted 473 out of it. Okay, and then we have concatenated both fraudulent transactions of 473 and 473 legal transactions, and we have created a total 946 records data set. Out of it, I think we have done the input and output columns division. Then we have split the data set into training data set and test data set. We have created the model, and we have trained the model with the training data set, and we have predicted the values with the test data set. Okay, and our model accuracy score is 0.9. Okay, now the next thing is will be called as the oversampling. Okay, which is exactly opposite. Okay, legal dot shape. Okay, home print, or in simple terms, data dot class dot value codes. In undersampling, what we have done is we have identified the least number of transactions, which is fraudulent one 473, and same 473 we have taken for the legal ones as well. That's what we have done in the undersampling. So what exactly happens in the oversampling is exactly opposite. Okay, here we are going to create the transactions which are equals to this 283253. So by doing that, which will be, our model will be having a more data to get trained on. Okay, so we are going to make the fraudulent transactions from 473 to 283253. So how we are going to do? We are going to do it with the smooth. Let's import the smooth functionality. Smooth, and a random state is equals to 2. Okay, SM has been created. So now we have the data, right? This is the data. So this data set is having input data set, input columns and output columns. So let's split those things. Okay, x is equals to data dot drop columns is equals to class. So except the class column, so remaining all columns are the input columns. Okay, now y is equals to data of class column. Okay, so x and y has been created, x dot shape and y dot shape. Okay, here we have the 283253 as the legal ones and 473 are the fraudulent ones. As part of the oversampling, we have to convert 473 records. Based upon these 473 records, we have to reach this record count to 283253, which is similar to the legal records. That's what we are doing with the oversampling. Okay, here we have imported the functionality called SMOT. Okay, SMOTE from the IMB learn. Okay, oversampling. So how we are going to do is x comma resample, okay, or oversample, comma y and score oversample is equals to sm dot fit resample of x comma y dot ravel. Okay, that's it. Now let's check the y and score oversample dot shape. First check for the x and score oversample dot shape and y and score oversample dot shape and pd dot value and score counts of y and score oversample. Okay, if you see here, the legal transactions has been 283253, which is similar to the above one. Okay, 283253, but earlier the fraudulent transactions are only 473. Okay, but now the fraudulent transactions count also increased to 283253. Okay, earlier the total record counts was 283726, but it has been increased to 566506. So that's what we are doing in the oversampling. So what exactly happens is, whatever the transactions which are having less number of counts, we will make the this SMOT will do that. What exactly do we do in the oversampling is, we will create the similar number of transactions which are equivalent to the legal ones. So fraudulent records are increased from 473 to 283253. Now our data set is balanced one with oversampling, not with the undersampling. Undersampling, what we are doing, whatever the more number of records, we are reducing it to the less number of records. Here what we are doing, we are increasing the less number of records category into the equal number of the records count. That's what we are doing in the oversampling. Okay, so now our data set is ready, x oversample. Now let's split the data set into train test data sets. Okay, x and score train and x and score test, y and score train and y and score test is equals to train test split x and score oversample y and score oversample. Okay, and test size is equals to same 0.2. Okay, that is done. Now print x and score train dot shape and x and score test dot shape and y and score train dot shape and y and score test dot shape. Okay, if you see here, the record count has been 453204 is the train dataset count and 113302 is the test dataset count. Okay, now we have split the dataset. Now what we have to do is, we have to do the scaling of the data. Okay, x and score train and score scale is equals to scalar dot fit transform of x and score train. Okay, same way we have to do it for the test dataset as well. Instead of train, it will become test, and here also it will be test dataset. Okay, scaling of the dataset is done. Now we have to create a model. Model 2 is equals to Logistic Regression Machine Learning Model. Okay, and I'm training this model with the test dataset and training dataset. X train and training this model with the input dataset and output training dataset. Okay, our model is being trained, still running. Now it's done. Okay, our model is trained. Now let's predict the values. Predictions is equals to model dot predict for the test dataset, which is x underscore test underscore scale. Okay, correct. Here not the train, then it should be scale dataset. Okay, it should train on scale data so that it will be predicting the values on the scale dataset. Okay, now we have to find the accuracy score between prediction values with the actual values, which is nothing but the y test. Okay, it is 9.5. If you see here, with the undersampling, the performance is 0.9, and we have increased that 0. We made it as a 0.95 accuracy score for the oversampling. Okay, let's see what we have done now. Okay, so far, so what we have done is we have imported the necessary libraries, and then later what we have done is we have read the data from the CSV file into the pandas data frame with the data, and next we have just printed the first 5 rows from the data set with the data.head. Okay, here we have the columns, total 31 columns are there. One is the time and remaining one v1 to v28. So these are the variable columns which will be used, which will be encrypted the columns. Okay, to not to identify the merchant and the customer details, as it is a very sensitive data. And next one is an amount field, and the next one is the class. It says that whether the particular transaction is a fraudulent one or a legal one. If class is equals to 0, that means it is a legal one. If it is 1, that means a fraudulent transaction. Okay, and we have searched for the data.info. So data.info gives us the total column wise data type, and whether that particular column is a non-null or null values. Okay, and the data type of the column. Okay, so all out of 30 out of 31 columns are the float 64 columns, and only one column is called as an integer column. Now the next what we have done is we have checked whether the null values are there in the data set or not. So we don't have any null values, so we don't have to worry about anything. Then we have just print the shape. So total 284807 entries are there with the 31 columns. Here we have just dropped the duplicates. If there are any duplicates are there, so we just drop those duplicates. So after removing the duplicates, our count has been reduced from 284807 to 283726. Okay, almost 800 columns are having the duplicate records. 800 rows are the duplicate rows. Okay, next we have removed this column, time column, which is not going to make any sense, right, to predict whether the particular transaction is a fraudulent one or a legal one. So we have removed the time column. So after removing that, so we have been left with the 30 columns. Okay, so then we have just checked for the class column. So we came to know that we have more number of legal transactions and we have only less number of fraudulent transactions in the data set. So our data set is a highly imbalanced one. Okay, for that one what we have done is we have taken this legal transactions into one data set and fraudulent transactions into another data set. Okay, so 283253 are the legal transactions and 473 are the fraudulent transactions. So when we just check for the legal transactions amount and fraudulent transactions amount described, so we came to know we don't see much of the differences, but most of the looks same, but only the maximum value in the legal transaction is like 25k 691, but in the fraudulent transaction it is just 2125. Okay, and so as we have this kind of imbalanced data set in the class legal versus the fraudulent transactions, so we have two methods to fix that. So one of the method is called as undersampling and another one will be called as oversampling. In undersampling what we are doing is we are just taking the fraudulent transactions 473 as it is. As we have more legal transactions, we are taking only the sample 473 which is equivalent to the fraudulent transactions count. So we have taken only 473 out of the 283253 for the legal transactions, and total we have concatenated total both the legal sample and the fraudulent transactions. We have created data set with the only 946 rows. Okay, so after the 946 rows data set has been created, So there we have the legal transactions as 473 and fraudulent transactions as 473. So now we have the equivalent balanced data set. Okay, now we have the balanced data set. So once we have the balanced data set, we have split the data set into identifying the input parameters versus the output parameters. So except the class, all the remaining columns will become the input data set, and the class will become the output column, output data set. Okay, and here we have just split the data set into test data set and training data set. So 80% of the data goes to the training data set, and remaining 20% goes to the test data set. So 756 columns out of 946, 756 rows out of 946 rows goes to the training data set, and 190 out of 946 goes to the test data set. And here we have scaled the data set with the standard scaler. Okay, this extend data set and test data set. And here we have created the logistic regression machine learning model, and we have trained the model with the scaling data of the training X and with the Y train. So, and then we have predicted the values for the test data set. Okay, and we have compared these predictions with the accuracy score of the predictions with the actual values of Y test. We got the score of 0.9. Okay, that's what we got with the undersampling. The next method we have the oversampling, which is exactly opposite to the undersampling. Here we have the legal transactions as 283253 and fraudulent transactions 473, right? So with the help of the SMOT, what we have done is we have increased the fraudulent transactions from 473 to 283253, which is equivalent to the legal transactions. Okay, that's what we had done. So after doing that oversampling, so we got the total record count as 566506. Okay, and which is having the both legal and fraudulent transactions are equal number of transactions, which is 283253 transactions. Okay, after that we have split the data set into test data set and training data set. 80% of the data goes to the training data set, and 20% of the data goes to the test data set. And here 453204 out of 566506 transactions are the training data set. 113302 out of the 566506 transactions are the test transactions. And finally we scale this training data set and test data set, and here we have created the same model, logistic regression model, and we have trained the model with the train data of the X with the Y train model, and we have predicted the values for the test data set, and we finally found the accuracy score between the predictions versus the actual values, which is Y test. So finally we got the accuracy score of 0.95 for the with the approach of oversampling. Okay, and yeah, this is pretty much. So this is based upon this machine learning model. It will be able to identify whether that particular transactions which is happening against the credit card is a fraudulent one or a legal one. Okay, and as we have the more number of v1 to v28, right? So total 28 columns are having the 28 to 29 columns are having the encrypted data, so hence we are not able to create a web application out of it. Okay, so that's the reason I'm not creating the web application in the Streamlit for this tutorial. So otherwise I would have been created it, but this is it. That's it for the credit card fraudulent transactions machine learning model. Okay, if you like the content in this video, please do like and subscribe to our channel. Thank you all. Thanks for watching this video.